Okay, we left off yesterday. We were talking about those trig functions and calculating them on the calculator. So I just want to review a little bit before we move on. If I asked you to find the secant of 40 degrees, what keystrokes are we going to use to find that?
Sine.
Careful.
Cosine.
Secant goes with cosine. So cosine 40 degrees, make sure we close the parentheses and then hit that x negative 1. Did you have secant should go with cosine, cosecant should go with sine?
I was looking at the cosine.
Yeah, cosine
Goes with sine. So that gives us 1.305. So now let's say I ask you for the cotangent of 10 degrees. So you're going to do the tangent of 10, close the parentheses, and then the x negative 1. That sounds right. Oh, you got to do the x negative 1. Use your 5.671. So you got to do the tangent, type in the 10, close parentheses, then hit that x negative 1 key. You didn't do the x negative 1 is all. So how about cosecant of 70 degrees? There you go. That sounds about right. $1.064. Now, how about secant of 20 degrees? $1.064. Good. How about the tangent of 80 degrees? 5.671. And the cosecant of 50 degrees. Don't know if you caught what I did there, but this was the secant of 40 degrees. This is the cosecant of 50. 40 and 50 are complements. They add up to 90. So the secant of one should be the cosecant of the other, and they are. This was the cosecant of 70. This was the secant of 20. Again, 70 and 20 add up to 90, so they're complements. The secant of one should equal the cosecant of the other. And the same here, tangent and cotangent. 10 and 80 are complements, so the tangent of one should equal the cotangent of the other. Okay, well, today we want to look at finding these from a triangle. So let's say that we have this triangle here. Or this is going to be, I'll do this. A, B, C. Sides of length 6, 8, 10. If I want to find the sine of angle A, sine is what sides? Opposite of hypotenuse. Here's angle A. According to angle A, what's the opposite side? That would be the 6. The hypotenuse? 10. 10 should always be the hypotenuse. So I could leave it as 6/10, or I could do it as a decimal of 0.6 if I wanted to. How about the tangent of angle A? Tangent is opposite over adjacent. Well, the opposite is the 6. The adjacent would be the 8. So 6 over 8. Again, I could leave it as a fraction, or I could divide it out to get 0.75. How about the cosine of angle B? Cosine is adjacent over hypotenuse. But when we're looking at angle B, if we're looking at angle B here, which side is the adjacent side? The 6 is. The 8 would be the opposite according to angle B. So the adjacent side is the 6 over the hypotenuse of 10. 6 over 10, or 0.6. Again, we pointed this out yesterday, but since A and B are complements, the two angles in the right triangle, they have to add up to 90. The sine of one equals the cosine of the other. Find the secant of angle B for me. Secant is hypotenuse over adjacent. .66. Hypotenuse is 10. The adjacent side would be the 6. You're thinking you did the secant of angle A. Yeah. So 1.67 is that secant. Find the cotangent of angle A. Cotangent's adjacent. Perfect. Adjacent over opposite would be 8 over 6, or 1.33. Cosecant of angle B. Cosecant is hypotenuse over opposite. So hypotenuse is 10. The opposite is going to be the 8, because we're looking at the angle B. That is 1.25. So you have to be very careful finding these. Because you have to be careful what angle you're at. A lot of people, they want to just say, oh, we're looking at this angle, this is always opposite, this is always adjacent. You got to be careful. We might look at the other angle, they switch spots. That's where I see most of the mistakes get made on those. So we can find the functions from the sides of the triangle. We can find the functions in the calculator. Let's start going the other direction with these. If I tell you that the function, let's say I tell you that the sine of angle A is 0.734. Well, in math, we have all of our operations come in pairs. You know, we've talked about addition and subtraction being pairs. They're inverses. They undo the other. We talked about multiplication and division being inverses. They undo each other. We talked about powers and roots. You know, x to the third power and the third root of x. They undo each other. And we even did a few weeks ago logs and exponentials. 3 to the power of x and log base 3 of x undo each other. Well, in our trig functions, we have inverses as well. We have the trig function and its inverse. So for sine, the inverse of sine is the inverse sine. The inverse sine can be expressed in a few different ways. We can either write out just INV-SIN for inverse sine. We can use arc sine is another notation that's used for it. And then this is the button you were asking about the other day. There's a sine -1. That's inverse sine. All of those mean inverse sine. So if any of them are applied to this, it cancels out the sine. So my sine of A equals 0.734. To undo that, I am going to do, the most common notation I use is the sine -1. So that inverse sine cancels out the sine on the left side. And we're left with A, sorry. On the right side, it's inverse sine. And I calculate secant and then sine, the inverse sine, 0.734. Because it's 47.22 degrees. And each of our trig functions have an inverse. If I tell you that the cosine of angle B is 0.359, how am I going to find angle B? It's going to be the inverse cosine. So the cosine and inverse cosine cancel out. B equals the inverse cosine, so secant cosine, 0.359. 68.96 degrees. What do you think? Good stuff? The angle, yes. We're given the... That's where we're going next. Yeah, the reciprocal has to come in a little bit different spot when we're doing inverses, but I'll show you where that comes in. Let's say I tell you the tangent of angle D is 3.7. How do we find the angle? It's the inverse tangent. So again, tangent and inverse tangent cancel out, giving me D. Inverse tangent, second tangent, 3.7. 78.88. Sorry, 74.88 degrees. Is angle D. Now, secant, cosecant, and cotangent are a little trickier. We don't have those keys on our calculator. So when we calculated them, we had to go through some keystrokes. So let's look at secant first of all. Now I'm going to start out by doing the angles. Let's say we have the secant. We want to find the secant of 55 degrees. Remember on our calculator we did cosine 55 and then did the reciprocal. That gave us that value. So 1.743. What's that? Well, now when we reverse this, that's exactly what we have to do. We have to do everything in the opposite order, backwards order. Here the reciprocal is the last thing we do. If we're doing a inverse secant of 1.743, we have to do the 1.743 with the inverse first, and then the inverse cosine. So the way you would enter it is just like this. On the button, you're going to hit secant cosine. You're going to type in the 1.743, but this time you hit the x -1 before you close the parentheses. Then hit enter. Gives you the 54.99 degrees. So it's not exact. We started out at 55 degrees. That's just our round off errors. So cosecant of angle F equals 5.38. To find angle F, well, what trig function goes with cosecant? Sine. So we do the inverse sine, put in the 5.38, and the reciprocal key goes inside the parentheses. So it's secant sine, 5.38, hit the reciprocal, then close the parentheses. 10.71 degrees. Or if I tell you that the cotangent of angle G equals 1.33, how do I find angle G? Well, it's going to be the inverse, not cotangent, the inverse tangent. 1.33 with the reciprocal inside. 36.94 degrees. What do you think? Okay, that's actually a very good question. If you did not have a calculator, they would use trig tables. Oh, this one looks like a good one. It's big enough to read. Maybe not. They're trying to sell you something here. Engineering toolbox that they're trying to sell. Here we go. There's trig tables we can read. Here's your degrees. You know, from 0 through 90. So let's say if I didn't have a calculator and I wanted to find the sine of 15 degrees. Here's 15 degrees. There's the sine. 0.55 or 0.2588. If I want to do the inverse sine of an angle, so let's say I want to do the inverse sine of like 0.77. Well, I have to look in the sine here. 0.7. Here's 0.7660. Here's 0.777. Which one's closer? This one's probably closer. 0.766 is closer to 0.77. So that is 50 degrees. So the inverse sine of 0.77 is about 50 degrees. It's actually somewhere between 50 and 51, but that's about as close as we can get. They had these tables. I've seen these tables that are down to the nearest 10 or 15 minutes. So you can look at it. So then obviously they're a lot bigger. Then you have to look at it. So, okay, this would be, and it probably would have something really close to 0.77 on there. And then you can get it down at least to the quarter of a degree instead of the nearest 1 degree. But that's nuts. In fact, I actually have a book up in my office that has the trig tables down to the 10th of a degree, but it's like 12 or 15 pages. So it was not pleasant to do. And then if you wanted to do like a secant, the inverse secant, well, let's say you want to do the inverse secant of 2. But first you have to do the reciprocal of 2. So 1 divided by 2 is 0.5. So then secant and cosine go together. So you look at cosine and find 0.5. Well, here's exactly 0.5. That's 60 degrees. So the inverse secant of 2 is 60 degrees. So you'd have to do that 1 divided by, do that reciprocal by hand. Which is loads of fun. Basically, let's pray that our calculators keep working. There was a show on a few years back. It was called Revolution. I don't know if anybody saw it. Yeah. There was some nanobot or whatever thing that they released, and it destroyed all technology. It basically ate. Well, it didn't eat, but it stopped computer chips from functioning. Well, everything with a computer chip in it stopped working. All the electrical grid went down. There's no electricity. And it was basically a major reset on society. Kind of an interesting look.
A lot of people have died.
There were a lot of people that died, I'm sure. But even something like this here, I don't have a paper copy of the trig tables. So to even use the trig tables, I had to look them up online. Mm-hmm. Well, so the people that actually have this stuff in paper copy become incredibly valuable because you can't look it up online anymore. The whole, a lot of people don't memorize procedures anymore. They just pull it up on YouTube on their phone and they follow along as it goes. there's a lot to be said about the issues that can come of that. Now, I might ask you to do some of these inverse functions to the nearest degree, minute, second. So if I want it in DMS, exactly. So let's say that we tell you that the secant of angle B is 2.75. So we're going to do the inverse cosine. 2.75 x negative 1 before we close parentheses. Which gives us, something went wrong there. Let me try that again. (68.676 degrees). So now I'm going to go and change that to DMS. Gives me 68, 40, 35. 68 degrees, 40 minutes, 35 seconds. You could have done that as 34.7 seconds if you'd have wanted to. I usually just go to the nearest second, 35. I think at this point, it's best if we practice some. We had that worksheet from yesterday. Did you guys get that all done? Did you, that page 345, 346 worksheet? Anybody have any questions on it? No, we're looking good. Good deal. So now I'm going to have to give you a new packet today, I believe. I think I'm at the end of the packet I gave you. In this new packet, it's going to be page 689. Exercise 33-2. 1 through 15, the odds. Page 691. Exercise 33-3. 1 through 9, the odds. Page 693, exercise 33-5A, 1 through 29, the odds. And finally, page 693, not 696. 693 here. Page 694, exercise 33-5B, 1 through 21, the odd. I'll get that packet out to you right now.
In case you haven't noticed.
No.
There's no roll. Yeah. Oh, this one's good. I was gonna say, geez, whole book. That was all one right there. They can't Hunter.
Oh, no, that's two of them for him.
Old Smith.
That's just my label, so I know what it is. That's out of the old Smith textbook. That's the textbook
Oh,
that,
this new Smith package. The other one.
yeah.